All right, so factors and multiples is the third chapter that we're going to be working on. At the top of each note sheet and assignment from now on, you're going to see what the essential question is, and it is, how do you use equivalent rates in the real world? And this is what we want to make sure that we can answer by the time we are done with the chapter. So a lot of our problems and assignments are going to be about different rates and different topics in the real world. So some of this vocabulary here: product is the answer to a multiplication problem. Numbers multiplied together are called factors. Numbers with factors of 1 and itself are called prime numbers. And you've probably heard about those before. So it's only 1 times itself is the only multiplication problem you get to find your product. So can I find all the numbers between 1 and 20? Starts at 2, 3, 5, 7, 11, 13, 17, 19. So those are all the numbers that only 1 and itself are the factors to get that number as a product. So how about 30 and 40? Can I find all of them between there? Well, 31 and 37 are the only 2 in there. You might be thinking, well, 33, because 3 is a prime number, but 3 times 11 is 33. You might also think 39, but 39 is 13 times 3. So this is where knowing your multiplication facts is going to be extremely important. If we go on to the greatest common factor, it is the largest factor shared by a group or set of numbers. So I'm going to put my answer up on where it says GCF for 12 and 28 would be. And I like to start with my factor that's the easiest, 1 times 12. And then I'm going to do 2 times 6. I'm going to go to the next number, 3, which is 3 times 4. So those are all of the factors that go into 12. So when I get to 28, I have 1 and 28, 2 and 14. 3 doesn't go in there, so I skip that. And then 4 and 7. So when I take a look at this, the largest number that both of them have in common is 4. And so that would be my greatest common factor. Okay, so think about that. Greatest common. Greatest, biggest number. And then common, which one is the biggest in both of those numbers. So LCM, or least common multiple, is the smallest multiple of a group or set. And so multiple, you could do like 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Or you can just add that digit or add 4 to the next number over and over again. So 16, 20, 24, 28. Multiple for 6, we're going to go 12, 18, 24, 30, 36, 42. And so I'm looking for the smallest number in both lists, and it's 12 here. When you're on your assignment, if you come to that number right away, like if I wrote down this 12, I can stop right there if I know that's going to be the smallest one. I don't have to list out super far. So those are two ways you can find the GCF and the LCM. Now, coming down here for the greatest common factor using a factor tree, this is a lot of times going to be easiest if you have really large numbers. What I'm going to do is I'm going to pick two numbers that multiply to get 12. So I'm going to do 3 times 4. And then I'm going to break 4 into 2 times 2. So I'm looking for prime numbers. For 18, I'm going to do 2 times 9 and 3 times 3. So prime, prime, prime. 6 times 3 would also work. You would just have to break the 6 down a little bit farther. And so my rule is I'm going to only use common factors to find my GCF. So both of them have a 2 and both of them have a 3. And so I'm going to put those together, starting with the smallest number. 2 times 3 equals 6. So my GCF equals 6. So like I said, using this for when you have really large numbers is when it's going to benefit you the most. And then when we're looking at the least common multiple, so I'm going to do 2 times 7, and I'm going to do 3 times 7. So my rule here is I'm going to use each number once. So like I see that there are 2 7s here, I'm only going to use that number one time. So I'm going to put 2 times 3 times 7. 2 times 3 is 6. 6 times 7 is 42. So the least common multiple equals 42. So that was like if we would have listed the numbers. So if we would have done 14, 28, and you kept going, you would have to get to 42 before you found the smallest number that go into both of them. So I'm now going to ask you to use a factor tree to find the GCF of 32 and 48. So 32, 48. So I'm going to do 2 times 16. And I'm going to do that because I got a prime number right away. Then I get 4 times 4, 2 times 2, 2 times 2, and there I'm all done. Okay. Moving on. 48, I'm going to do 6 times 8, 2 times 3, 2 times 4, 2 times 2. So now I need to pair up numbers from both of them. So I'm going to pick this 2 and this 2. So I'm going to do 2 here, this 2, and this 2. So here, and this 2, and this 2. So I don't have any other. I think this 2 and this 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the greatest common factor that both of them have is 16, which 16 times 2 is 32, and 16 times 3 is 48. So that makes sense. And then going on to the LCM. So this time I actually give you 3 numbers. I give you 12, 15, and 18. So 3 times 4 and 2 times 2. 3 times 5. It's really nice when they're already both prime there. 2 times 9, and 3 times 3. So again, I need to find numbers that I can pair together. So these two, that makes my 2 here. Then I can go 3 here and 3 here. Then I'm going to go these 2 3s. And then 5. And then I have to use my last 2 that didn't have a partner. So if I do this, 5 times 2 is 10. And then I have 2 times 3 is 6. 6 times 3 is 18. So now I have 10 times 18, which equals 180. And so my LCM equals 180. And so you see how if you have much larger numbers, I would not want to list out all of the factors or all the multiples of these numbers because it could take a long time. The last problem here, so this is supposed to be something that is review, reducing a fraction into simplest form. So I need to figure out which number or which is the largest factor that's going to go into both of these. Well, I know that 7 goes into each of them, so I'm going to divide both the top and the bottom by 7 to get 3/5, and that would be my final answer. So use this to fill out your note sheet or to help you with your assignment.